So we mostly discuss about the linear motion, right? Till now we have different concepts related to the linear motion. We know about the variable concept, we know about the constant factors. So in this chapter, only one concept is remaining that is very new for you, that is projectile motion, right? Let's suppose if you throw something in horizontal direction from some height, so that will cover a distance in like in semicircular form like this. Or if you just launch something, or just if you kick the football, so it will cover distance in semicircle form, right?
Yep.
Basically that is the concept of projectile motion. Projectile means the old machine, you know, that the catapult machine is there, and we used to throw different objects from one point to another point, just like the concept of the missiles, because missiles will also work on the same motion, so that you need to know about the angle, the trajectory, the range. So that is the new concept in this chapter. So from next class we will discuss that chapter. Before that, let's try to apply this equation of motion that we studied in our this is from summer 22, because in other papers, in other variant of summer, there is no question related to the equation of motion, but in second variant there is a concept of equation of motions, right? So let's suppose if we consider the question, so a man is standing on a wall, throws a small ball vertically upward with a velocity of 5.6 meter per second. So this is the velocity. And second thing is the ball leaves his hand when it is at height of 3.1 meter. So this is the height
Okay.
that is also marked in the diagram very clearly as shown in figure. Okay. So air resistance is negligible because we know that it will also affect the motion of the body. So show that the ball reaches a maximum height. Okay.
Okay, so we're gonna use the v square equals u square plus 2as
Yes, very
formula,
good.
right?
So basically we need to use the equation of motion, and your equation of motion will be v square minus u square, right? And we know that if we start from the basic, so what will be the value of a? Okay, now remember one thing, whenever we are solving the equation of upward and downward motion, so your
Mm-hmm.
acceleration will be completely equals to acceleration due to gravity, right?
It's 9.82
Yes.
or 9.81.
9.8 point, yes.
So what we're gonna do is
And
u
one more
u
thing.
is five point
Yes.
six.
One more thing, if body is moving in upward direction, so we are moving opposite to the acceleration due to gravity or against the gravitational force, right?
Mm-hmm. So
We
it's
are
gonna be
moving
negative.
upward. Yes. So for upward, we are going to use negative sign, and for downward, it will be positive. So this is the only different concept. So now we know the value of A, and we can easily substitute in minus 9.81 multiply by the distance. Distance is what will be the total distance that we need to write over here?
Um, is it gonna be 3.1?
Okay, basically we need to find out the distance, right? Yes, show that the
Yeah.
ball reaches the maximum. So basically S is unknown.
But we
And
know that it's gonna be like less than 3 point. It's gonna be more than 4.7.
so
Like it's
final,
going.
yes. So basically final velocity is mentioned, and we know that initially the ball is at rest, right? Because
Mm-hmm.
there is no reference of initial velocity, just like the graph we use for the reference of derivation. So initial will be 0, and your final equation, right? And we are only using this minus sign Okay, basically, one more thing. We made a mistake over here. Basically, in question, they used to write a man is standing on a ball, throws a small ball vertically upward with velocity above the ground. Okay, so when ball reaches the maximum height, so ball starts with some velocity that is 5.6, because that is the velocity with which the ball is thrown in upward direction, right? And they are talking about the maximum height. Maximum height means after reaching the maximum height, so ball will change its direction, right? So very short, for very short time interval, the ball will be at rest state at the maximum height, right? Just
Okay.
like if you want to take a u-turn, so you will decrease your speed, right? And when you
Yeah.
are changing your direction, so basically you are at the same point. So it means that you are at rest state because your distance is not changing, only your direction is changing. So that's why maximum point we consider, this is for upward situation. If we are moving upward, so our final velocity will be zero. And let's suppose if we want to write for the downward motion, so in downward motion, your initial velocity will be zero and your final velocity will be something, right? For downward,
Okay.
because we know that if we throw something in upward direction, so at maximum height velocity will be zero. So, so during upward motion, our initial velocity will be equals to some value, but final will be zero. And when ball starts to move in downward direction, so then its initial velocity for downward motion only. Now just split the upward from downward. So when we are talking about only downward motion, so we starts from zero and reaches some point. Okay. So in this equation, we need to write like this. Here, final velocity will be equals to zero. Initial velocity is 5.6. Because if they write that ball is thrown from the rest, so then we use initial velocity zero. But there is no concept of the rest state in the question. So your final velocity at maximum height will be zero. So this will also give you minus sign, and both minus sign will cancel out in numerator and denominator. And you will get your final height, that will be equals to, okay. Now you know that already ball covers 3.1 meter from the ground. This is originally added in our experiment. So what we need to do, we need to add 3.1 plus our answer 1.6. So for the maximum distance, we need to add, because in question they mentioned show that, it means you need to prove this value, that distance will be equals to 4.7, and you are getting the same answer, right?
Yeah. So you have to like show step by step.
Yes. Now the second part is the interesting one, because what happens, the man does not catch the ball as it falls. It means it started from 3.1, but the man is not able to catch the ball at the same distance. So it means that now ball is moving in downward direction and covers more distance as compared to the upward motion, right? Because
We
3.1
should
is
use the,
already there, right?
we should,
Ball,
yeah,
yes,
we should use the other equation, the
yes,
s equals t plus half
very good.
a
Because
squared.
you know that, yes. So your motion will be like this. We start
And then
from this point,
so
but
then we
we,
do like
yes.
1/2 times 9.81 times like t squared.
So you know the equation, so you just need to substitute the values. S equals to ut plus half at square. And now this time we know that downward motion of a will be positive.
So it's 0.98 seconds.
Yes. This is 4.7. We already calculated from the ground. And the value of u is now 0, right? Because we are talking about downward motion.
Yeah.
So for downward motion at maximum height, initial velocity will be 0. Now they are talking about the time. So time is unknown till now. So we are finding the value of time from this equation. So this will be equals to 4.7 multiplied by 2 divided by is equals to t square, right? So just multiply the quantities and divide by 9.81, and then we just take the under root. Okay. So your final answer will be equals to around 0.98.
Yep. Because once you like do the division and stuff, you're gonna get 0.958. When you take the square under root for it, you're gonna get 0.978. So you just
Okay.
round it to 0.98.
So this is the time for the distance traveled from the ball from the maximum height to the ground level in downward motion. And the next part shows you the graph. And in this graph, the ball leaves the man hands at time t is equals to 0. Okay. So we need to start from t is equals to 0. And it hits the ground at time capital T. On graph is sketch a graph to show the variation of the velocity of the ball with the time t till time capital T. Numerical values of v and t are not required. So basically we are not working with the values. Only the thing that you need to require, assume that v is positive in the upward direction. So basically for upward direction, we need to take the positive side in the graph, and for the negative, we need to take the downward motion, right?
All right.
So basically what we need to do for upward motion and for downward motion, this is speed time graph, right? And for a speed time graph, we know that the downward motion covered by the body is greater as compared to the upward motion, right? Why? Because we know that when ball is thrown in upward direction, so we cover a distance of 1.6. 1.3 is already there, right?
Yep.
Okay, so basically we need to draw the graph, and for the graph we know that for initially we throw a ball in upward direction and ball covers only 1.6 meters, right? Right? And for downward motion, ball actually covered total 4.7 meter, right?
Yeah.
Because 1.3 is already there, sorry, 3.1 is already there for upward motion. So it means that when we mark a graph, that's why your graph is for 3 mark, because there is a concept behind it. Because some students do like they just draw with equal ratio on both sides, right? Same with the positive side and same with the negative side. Okay. But you know that
Okay.
a body covers only some distance in upward direction, but it cover more direction in downward motion, because it cover more distance. So when you mark a speed time graph, so you know that with the gradient of the area under the curve of the graph, you can easily find out the distance, right? So let's suppose if we just consider 5.6 at any point in the graph, let's suppose,
Like up there, the solid line.
yes, if we consider, let's suppose this side positive and the downward side negative, and they mention that assume that v is positive in upward direction. So during upward direction we know that We started from maximum 0.6 value. At the maximum point, it will be 0, right?
Mm-hmm.
So we started from the maximum point, so our graph will start from the maximum height. Okay,
Right.
the downward, it will be 0, and final will be something. So if we want to draw our graph, so your graph will be like this. We just need to mark a straight line. Okay, one more thing. They mentioned that you need to mark till capital T, right? From T to capital T.
Okay. So
So
it's
this
gonna
is
be a
your
straight line.
graphical representation, yes. Because you know that speed will remains constant because air resistance is negligible.
Mm-hmm.
But from 0, if you consider, and if you try to find out the area under the curve, so it is clearly shown in the graph that the upper triangle gives you a short distance.
And the other one gives you greater distance.
So that will make a clear concept that this graph is clearly for the motion that we are talking about, right?
Right.
Because sometimes students they just start from this point and mark till the edge of the graph. So that will give you same ratio on both sides, right? So that is the question they are asking for 3 marks, right?
We need different ratios as well.
Yes. Yes. Because from speed time graph, we know that the area under the curve also shows the time distance. So we also need to take care of that in this question. That's why question
Mhm.
is for 3 mark. And
The
part D is
next
very
one,
simple.
acceleration.
Acceleration.
And
Okay.
then the next part, we know that um the magnitude of the acceleration is gonna be same, right?
Okay.
But then the speed which they hit the ground with, they're also the same.
Okay.
Only like the direction will be different, I guess.
Yes. Only direction will be different because we know that there is no air resistance, and under the influence of gravity, we know that the magnitude of acceleration will be remains same, right? Because the graph also shows you the same thing, a straight line.
Yep.
And I think this is the easiest question from the kinematics for 10 marks, right?